Welcome. In this video, we'll take a look at an implicit derivative. We have an equation x squared plus y cubed equals 4, and we'd like to go out and find dy dx, the derivative of y with respect to x. So we'll see right off the bat this equation with y's and x's, this cannot be represented y equal to a function of x. That is actually impossible to do here. So we're going to have to find a different way than what we've done before to take this derivative. And taking a derivative implicitly is a way we can take the derivative of a function that cannot be expressed explicitly as a function of x. So let's consider this function and how we would want to take its derivative. I'm going to want to take the derivative dx of each side of this equation. So the derivative with respect to x of both sides. I'd write it like this. Now I'm going to go term by term on both sides and take the derivative with respect to x. So if I considered x squared, the derivative with respect to x here would be just 2x, just like our normal derivative. If I take the derivative with respect to x of a y term, y cubed, well, here we would be treating this like a chain rule. The outer derivative, we could say, is equal to 3y squared. That would be the outer derivative. Now, if I take the derivative of the inner term, which happens to be the y itself, the derivative of the y itself, we would call dy dx. So whenever we're representing a y term here and taking its derivative, we need to attach this dy dx because of the chain rule involved here. So that would be the derivative of the left side of that equation. And if I take a look at the right side, dx of 4, a constant, is always going to have a derivative of 0. Now I can go out and solve this equation for my dy dx, my derivative of y with respect to x. So I can subtract both sides by negative x. I'll have 3y squared dy dx is equal to negative 2x. And then, last but not least, I can divide both sides by 3y squared. And I'll have my dy dx, the derivative of y with respect to x, is equal to negative 2x over 3y squared. So we'll notice that the derivative here of the y function with respect to x is dependent on both x and y. So that usually is the case with our implicit equations, but not always the case. But this is not a odd occurrence. So here is our implicit derivative dy dx. Hope this is helpful. If you'd like to see other examples, go ahead and check out the next video in the playlist.